This is a story about challenges.
And this is a story about robots.
But this is more than just a story.
It's a chance to tackle some of the most daunting challenges facing NASA.
And the capabilities unveiled will usher us
into the next era of space exploration. I'm Molly McKinney.
And I'm Caleb Kinchlow.
And this is NASA 360.
So here we are again at NASA's Sample Return Robot Centennial Challenge.
That's right. It's year 3 and 18 teams have accepted the challenge.
NASA's Sample Return Robot Challenge is all about finding uncommon solutions to unique problems. Not just for NASA, but for the whole world.
Teams who compete must design and build a robot capable of finding and retrieving samples from multiple locations independent of human interaction or earthly navigation like GPS or a compass. Once the robot's turned on, it's on its own, and it's not as easy as it sounds.
For 2 years, teams have met on the field, testing the robots and pushing these complex machines to their limits.
Last year, 2 robots were able to locate the pre-cached sample, pick it up, and head home. One team even walked away with Level 1's $5,000 cash prize, while the other team's robot missed the mark by a few agonizing inches.
Despite the team's efforts, the big $1.5 million prize remains just out of reach, sending many of these teams back to the drawing board.
And yet the challenge continues to grow, attracting more interest each year and more competitors to the field here at the Worcester Polytechnic Institute in Massachusetts. So, you want to tell them more about this year's competitors?
Absolutely. So check this out.
Teams are all over campus, working on their bots, making last-minute adjustments before the challenge gets underway.
There are so many teams participating this year, we decided to group them into 4 categories: the new, the old, the internationals, and the champs.
The new. These teams are vying for $1.5 million for the first time.
I'm just a guy with a robot, team of 1.
What brought us together was our mutual love of robotics and interesting projects and challenges.
We're actually from the same computer science robotics lab, so a lot of us are focused actually on the software, which many people think is the hardest part. But the downside was that we kind of made the mistake of neglecting the hardware kind of to last minute, so that's why we're kind of last-minuting a lot of stuff here, but our software is kind of stronger.
We sort of put something together on the side as a fun project for us to sort of practice our skills, see what we can come up with. And now we're here and we're preparing to do a run. Very exciting.
We're the only high school team to be doing this from my knowledge. We were offered this opportunity from Proctor's, and we took it up.
We're here as our first year. We're still learning a lot, but hopefully ours will be the magic that solves the challenge and is able to complete both levels.
We've kind of gone for the off-the-shelf solution. You know, everything that's plastic on there, with the exception of a couple of boxes, is printed on a 3D printer.
So the technology that we're developing here is actually meant to be as a proving ground for a long-term open source development framework for building cheap industrial automation systems.
If NASA has to put a lot of weight up into space, that's very expensive. So ours is extremely economical.
We spent a lot of time sort of engineering a nice mechanism that's very reliable. And then and it turns out we didn't spend quite enough time engineering exactly what to do with that mechanism. So I think that'll be very exciting to see what the software does with that. And hopefully we'll learn a lot so we can improve it the next time around.
We have this rover chassis. It's kind of similar to the Curiosity rover. At 8 p.m. they'll be taking the rover into impounds, and we don't get to see it.
Go home and cry.
Yeah, it's a long distance relationship from then on.
We're very familiar with what we're doing. It's just putting it all together is the real challenge, and we're hoping to sort of get better at that, so that in the future we're better at putting together systems.
We'll get out there and hopefully learn some good lessons from this year, and have some good data that we can take back and work on for next year.
It starts up properly, it leaves the platform and starts its search pattern. I'm thrilled. If it accidentally picks something up, I actually nicknamed it the blind squirrel. Because who knows, it could trip across something.
I think we'll get off the platform, we'll get to the cache sample, collect the cache sample, do a couple spins, return, and that'll be the end.
It has to work. Yeah. We said that a few weeks ago, and I think we're saying it again now. It'll definitely get off the pad. Confident in that.
Yeah.
Not sure where it's going to go from there.
Yeah.
Yeah.
hopefully it's not chasing people around trying to pick them up.
The Old. You've seen this group before, and they're back with bigger, badder rovers.
We are a returning team. We're excited to come back for our second year.
This is our third year. We were one of the first teams here to start out, along with a couple of the other ones.
The hardware is pretty much the same as it was last year, but I've added a lot more software, so it's getting more capable all the time.
This year we focused a lot on software because that was what I think hurt us most last year.
Oh, I see how it's done. And I said, I just need a couple more months to iron out the difficulties that I had last year, and I can do this. And the more I worked on it, the more I realized that this is still a very hard challenge.
Most challenging thing has just been starting fresh and figuring out what direction we want to go and what algorithms we want to implement and how we basically want to approach this year.
We're back for more.
The Internationals. These teams are here for the love of the game.
So we are one of the few international teams here in this challenge. So we won't be winning any prize money, but we are just fighting for the glory of it. We want to win just like everybody else.
But in terms of the learning experience and that we get out of this competition, I think it's great. It's a great time for all of us.
Being here, it's such an amazing experience, and well, it's in NASA. It's a NASA competition.
The whole challenge is a hard thing, really. From a robotic standpoint, when I looked at it initially, I thought it's not that difficult. But then I was wrong by a long margin. So it's actually quite hard.
I mean, it has such a high level. I mean, there are local robotics competition and there are national robotics competition, but it is not local nor national. This is international. This is like a top-notch competition, and it's NASA. I mean, well, it's awesome.
The champs. Last year's Level 1 winners, back for the big bucks.
So we are here with Team Survey, and you guys did very well last year. You won the $5,000. You know, Amara and I were just talking about this. You guys are pretty much a big deal.
All right.
We think so.
Okay, we think you're a big deal. So what are you guys going to do in round 2 to take home the big $1.5 million?
Well, you know, the big difference with level 2 is that the robot has to explore a lot of area. Level 1 and level 2 are really different problems. Level 1, you got to go to one specific place, you got to get there pretty quick, and you got to get right back to the start. And in level 2, it's kind of like a walk in the park, but not easy like a walk in the park.
a little bit hard.
Yeah. You just have to drive around, and you have to collect the samples, and you have to not get lost, and you have to make it back to the starting platform. So most of the stuff we've been working on this year has been focused on solving that problem.
What specifically do you think is it? I mean, beyond this competition, why do you enjoy this? Why is this such a passion for you?
Just trying difficult challenges and innovating. Innovating is fun to most engineers, and this is what this project is all about.
Centennial Challenges are amazing events. However, they are just one dimension in a much larger picture. A picture developed by NASA's Space Technology Mission Directorate, known as STMD. STMD focuses on cross-cutting new technologies and capabilities that have an impact both on Earth and off.
I'm here with Dorothy Rascal. Dorothy, can you tell us a little bit about what you do at NASA?
Well, I'm in the Space Technology Mission Directorate, and I'm the Deputy Associate Administrator for Management. We're a new mission directorate, and what we do is the execution and the implementation of the space technology projects. And so in our mission directorate, we have 9 programs. Centennial Challenges is one of our many programs, and our different programs help develop the new technologies for the future.
And how does that fit into the vision of NASA for the next 50 years?
So we're supposed to get to Mars with humans by 2035. And so we have all of these roadmaps that we have incremental steps to get there. We're testing certain technologies already in low Earth orbit on the space station, and then what our next step is to go and do an asteroid redirect mission, and from that we'll learn about the science about the asteroid. We will learn about the technologies that we can demonstrate, and then from that is the next stepping stone to utilize those technologies to get to Mars and then to deep space exploration. But each of these areas have a different step, whether it's propulsion, whether it's doing robotics, whether it's living within a habitat, Also, entry, descent, landing, which has its whole complexities, then living on Mars and living off the land,
Right.
and then returning safely.
So why is NASA's Space Technology Mission Directorate so awesome?
It is the coolest mission directorate to be in because it is developing all the technologies for the future.
Dorothy, one of the things I keep hearing competitors at this challenge talk about is how difficult they found it to be to actually complete one of these levels. Do you think that's a realistic example of what it's like being an engineer at NASA and pushing these technological boundaries?
It is. It's very, very difficult. And that's why we're looking for these folks to help us solve these problems. I'm an engineer and I love to solve problems, and listening to all of these different groups that come forward to help us solve the problem, to find a sample on Mars and return it. I mean, this is like the best way to get the best bang for our buck.
And here at the Sample Return Robot Challenge, pushing technological boundaries means building robots that act and react like humans. And as you can imagine, that is no easy task. Down, boy, really? Come on.
And WPI's Ken Stafford has insight on exactly what it takes. Ken, it's great to see you again.
Good to see you, Caleb.
Ken, you have a lot of different titles, you do a lot of different things. You are a judge coordinator, robot specialist, and you helped create this challenge.
I did indeed, Caleb, and it's been a lot of fun. Each of those roles is totally different, but it's all a challenge. I really enjoy it.
So with this challenge, how difficult is it to make a robot that's capable of picking up a sample and taking it back to home base?
Well, actually, the picking up is not too tough. In fact, even to direct a robot to go some particular place is not too tough under normal Earthbound rules. But understand, Caleb, this one's about autonomy. It's not just it has to be totally without any human interaction, but it has to be as if it was somewhere else. No GPS, no compasses, none of the things that we would like to use on Earth. So it's a big, big challenge.
And why can't the bots use a GPS?
Well, think about it. This is designed for an extraterrestrial mission. We want to have something go to the moon, to Mars, to an asteroid. And there won't be the kinds of things that people are used to using around here.
So there's no GPS, so how are the bots able to know what their surroundings are, locate the sample?
You know, if that was an easy answer, we probably wouldn't have a challenge here. Each of the competitors just has its own attack on this. You know, a lot of them are using obstacle avoidance with a LiDAR, which is a laser ranging device. A lot of them are using stereoscopic cameras. A bunch are using infrared range detections. So there's a myriad of different ways to approach this, and it's fascinating to see the different sorts of technologies and different applications of the same technologies on the different robots.
Now we've seen the bots, I mean, they're all very different on the outside. You know, that's hands down different. But what about the inside? Like, what makes them completely different?
Well, here at WPI, we understand what a robot is. A robot always has to have a soul. You know, and so in their soul, they probably have some similar characteristics. They have to have a lot of thinking, processing going on in there. So they're going to be one or two or maybe 3 or 4 computers in there doing a lot of hard work. So they may look totally different on the outside, but inside there's going to be a lot of similar sort of powerful computing that's integrating these sensors and telling it what to do.
What are we expecting to see in this year's competition?
Well, I'm expecting there's going to be a couple of people who are very, very happy. Not only me, but also I think some of the competitors. I think we're going to have some good success this year, but everybody else will come out with a real learning experience. That's the intriguing part about Centennial Challenges in general, Caleb. It does encourage a wide variety of folks, which is really good for the solution set. We have people that are PhD levels, we have people that are husband and wife teams, we have a high school team here, plus a bunch of university teams. And the fascinating thing is that they're all using similar technologies within their affordability, but their approaches are so radically different. And it wouldn't surprise me too much to see a low-tech solution do very, very well.
That's cool. When we come back, we put these technologies to the test as our competitors and their human counterparts go for the glory.
The Sample Return Robot Centennial Challenge consists of 2 levels. Now level 2 takes place tomorrow, which means today it's all about level 1. In level 1, the rovers must locate, pick up, and return the sample back to home base, all within 30 minutes. And if they are successful, they win $5 grand and a chance to compete in level 2.
Although 17 teams came to WPI intending to compete in level 1, only 13 rovers made the cut, and some of those rovers put on quite a show. Oregon State led the pack. The rover didn't locate the sample, but it did break the record for ground coverage at the Sample Return Robot Centennial Challenge.
Team Arrow hit the ground running, but stalled with the sample just in sight.
Wunderkammer Laboratory got off to a fast start, heading straight for the sample, but lacked a functional vision system, making it impossible to finish the task.
I'm happy that it did what it was supposed to do. It didn't burst into flames or fall over on the hillside, which I was sort of worried about.
The judge turned Team UCSC's rover on, but the operating system failed to boot, ending their run before it began. The Mountaineers left the starting platform and were off to a good start. The rover cautiously approached the sample, adjusting its position for the perfect pickup, but failed to grab the sample. So the rover readjusted and went back for a second try, and a third, and a fourth. And eventually, time ran out before it could figure out how to complete its mission.
The next rover lifted its arm, made its way off the purple platform, but a software glitch stopped Team Stellar Automation Systems in their tracks. The competition's only wooden rover, built by Team Fetch, exited the platform the wrong direction and ultimately cracked under pressure.
The only high school team ever to compete in any Centennial Challenge got off to an impressive start. But after failing to reach the sample, it was back to the drawing board for this team. One by one, Team Kokogur's arsenal of robots swarmed the field. The rovers were mobile, agile, and a little confused. One even came close to its target, but ran right over it. Eventually, time ran out, ending this team's run.
After a strong demonstration last year, there were high expectations for Team Waterloo. But ultimately, this Canadian crew came a long way for a smoke.
Teams Cephal and Formicalorum got the go-ahead, but the quirky little rovers each had a failure to launch. Team Middleman's Robert charged off the base, making a dash for freedom. Unfortunately, that also took the rover out of bounds, disqualifying it. That's it for Level 1, and despite everyone's best efforts, none of these teams qualified for Level 2, leaving the field wide open for Team Survey to bring home the gold.
We are back on the field and just moments away from the Level 2 competition. So Colleen, we've never had a Level 2. What's going down?
So level 1 was kind of the qualifying thing to see if people could do the most basic tasks, but level 2 is really difficult. Over the course of this entire park, there's 10 different samples set out, and they have 2 hours to search the entire course and find as many samples as they can and bring them back to the starting platform.
Okay, so before we had one sample, now it's multiple samples and a much larger space.
Correct. So in level 1, it's the pre-cache sample, which represents maybe there was a robot there before you that picked it up and left it there, and so you got to go get it. But now you want to go get that sample, but you also want to collect anything interesting that you might run into along the way.
Okay. So let's talk a little about the placement. Now with level 1, the robots were placed in the middle of the field and then had to scan and find their sample. So what about level 2? Is it the same or is it different?
So level 2, again, we want to represent what really might happen, which is your robot has to take a ride up to space. And so we put it on the platform outside of the park, we strap it on, and then a forklift brings it in and places it, and it's at an arbitrary angle because you don't always land exactly where you thought you were going to land.
We're making it as realistic as possible.
Correct.
So let's talk about the prize. $1.5 million, that's enough money to change someone's life. Why is this competition, and in particular this challenge, worth that?
Well, autonomous robots are really difficult because there's so many different factors that you have to take into consideration, and it's easy for us to look out and see like, oh, that's a red hockey puck, but for a robot to not only see it from a distance but recognize it and then know that it wants to pick it up takes a lot of time and a lot of effort. Systems need to be integrated. There needs to be mechanical, electrical, and programming all working together flawlessly for it to really happen.
Excellent. So it looks like the team is getting ready to go, so let's go and cheer on Team Survey.
Sounds great.
All right, let's go.
And the pursuit for $1.5 million begins. It's time for the moment of truth. Team Survey's bot has been positioned on the starting platform and activated. The bot normally takes 2 minutes to turn on, but 2 minutes has come and gone, and everyone is holding their breath. The robot is communicating, and it is not good news.
Checking camera status.
There appears to be a problem with the rover's optical system.
Camera failure, manual mode only.
And Team Survey agrees that their robot hasn't booted up correctly and unfortunately decides to terminate their run.
Call it. Done. I call it.
And so the challenge comes to an exciting close. And like any good competition, there were surprises and moments of great success. Let's see what NASA thinks about this year's competition.
Well, another successful challenge has come to an end. Sam, I believe congratulations are in order. So, do you think that competitors at this challenge accomplished the goal of pushing technological boundaries?
Absolutely, because we had level 1 and level 2 both run this year. We had more competitors than last year, so we're really pleased to see the advancements in the technologies that are coming in. For the level 2 competition though, Team Survey from California, they got the robot on the starting platform, but they weren't able to get going. Their camera systems wouldn't boot up. We did allow them to do a demo run, so they brought their computer out, they reset the systems within the robot, and we allowed them to go off and showcase what technology they do have. And we saw some really great advancements in there. Their sensing systems and their camera systems were able to find multiple samples out on the field. They found the orange stick, they found the red hockey puck. They were able to take those samples, actually find them, pick them up, and bring them back in. So we're starting to see successes and advancements in technology that we didn't see last year.
Do you think that this is a good example of a real-life process that an engineer goes through?
Very much so. So here at NASA, you always hear us saying failure is not an option. Well, that's true. Failure is not an option. It's actually a requirement. We really need to have these scenarios where we do fail and then find where the broken spots are within our systems.
And I guess when it comes to NASA, it probably makes sense to try and find all those bugs and work out all those kinks here on land before you send it into outer space, where it can be a lot more challenging.
Yeah, absolutely, because we wouldn't have the astronauts or anybody else to help do a repair on something like that. You want the failure to happen here on Earth so that your system would operate properly when you send it out to other planetary locations.
After NASA 360 packed up our cameras and left the Sample Return Robot Centennial Challenge, the competition organizers decided to give the competitors a second chance at level 1. And for the West Virginia Mountaineers, it really paid off, as they took home the $5,000 prize for completing level 1.
So another year has come and gone at the Sample Return Robot Centennial Challenge. And I have to say, this year's teams really went the distance.
Absolutely.
And I cannot wait to see where the technology will be a year from now.
I know, right? I mean, when you think about it, competitors in these Centennial Challenges are finding uncommon solutions that'll transform the way we explore, but they're also going to transform the way we live. And WPI is just the beginning. In fact, we'll see you at our next challenge.
Absolutely. I'm Caleb Kinchlow.
I'm Molly McKinney.
And this
is NASA 360.